we're going to talk about some things that are specifically Vanderbilt today, some things that you need to think about as a faculty member, a member of the Vanderbilt community, things that apply to all of us. And we're going to start out by talking, we're going to talk about several different things. One will be ownership of intellectual property. We're going to talk about conflict of interest, conflict of commitment. We're going to talk about the commercialization process, how we do things at Vanderbilt. We're going to talk a little bit about the licensing process because that's a big part of the commercialization process at Vanderbilt. So the first thing we're going to talk about is ownership of intellectual property and the policy on technology and literary and artistic works. It was adopted at Vanderbilt University about 20 years ago in 1993, and it's actually a very good policy. It was worked on and adopted by a faculty committee. There's some things looking back on it that you might wish were a little bit clearer, but they did a very good job, I think, on the policy. And the policy is very much like the policies that the universities have, and it's very much like the policies that companies have in terms of who owns intellectual property. The big difference, as you'll see, is how we share royalties. Companies don't share royalties. So, if someone invents something that works for the company, as you probably know, they get their paycheck next week. There's no sharing of royalties or anything like that. Universities do share royalties, and we've actually looked at our policy from time to time to see how it stacks up against other policies, like against other universities. And ours actually stacks up very well. It's one of the most generous, at least vis-a-vis inventors and creators of any that we've looked at. So we have great policy. Policy governs the ownership, protection, and transfer of technology and literary and artistic works created or authored by Vanderbilt faculty members or students. That's what the policy covers. And it also covers all rights and technology created by Vanderbilt faculty, staff, and students. So the first question is, what is owned by Vanderbilt? What technology is owned? And technology that is created with university facilities or funds is owned by Vanderbilt. It's owned by Vanderbilt. All rights and technology created by Vanderbilt faculty, staff, or students with the use of university facilities or funds are granted to the university. Again, a very typical policy. What are university facilities or funds? It includes research funds, R&D funds, use of support staff, Vanderbilt lab space, Vanderbilt equipment, long-distance phone charges, the use of Vanderbilt's name. All these things are the use of Vanderbilt facilities or funds. The second test, though, is suppose you didn't create it at Vanderbilt using any facilities or funds. So you create it in your basement at home. The second test, though, looks at, is this something that was in the scope of your employment? All rights and technology created by Vanderbilt faculty or staff and students without the use of university facilities, but that are within the scope of their employment are owned by the university. So the policy actually has some examples in there. Factors considered would be your recent teaching. Is it an area in which you teach? Is it an area in which you research? Obviously, a lot of people at Vanderbilt, there's a lot of research going on at Vanderbilt. Is it your research area? Is it an activity stipulated in an appointment contract? Or is it consistent with other university activities in which you're involved? All of those things are factors taken into account. So, an example of something that might not be owned by Vanderbilt would be you have an art historian who does what art historians do, but just happens to know a lot about chemistries and develops a valuable chemical compound in his or her basement. He or she probably owns that. There were no Vanderbilt funds, facilities used, and it's not within the scope of their employment. Obviously, the answer would be different if the person that created the chemical compound was a chemist at Vanderbilt. So those are the sorts of things that the policy looks at. There's also an exception. Vanderbilt does not make claims to something called scholarly works. And there's a discussion in the policy about what a scholarly work is. But essentially, it's publications used simply to disseminate information. There's a provision in the policy that talks about scholarly works are things that would be used to consider tenure. So it's going to be something that's very focused. If it's not that, then it's not a scholarly work, and it would be owned by Vanderbilt. Works for hire are something else that Vanderbilt owns, and the difference is the application of the technology policy, which we'll talk about in a minute, is different for works for hire than it is for inventions or creative works. So a work for hire is technology created as a specific requirement of Vanderbilt employment or as an assigned duty. Those are owned by Vanderbilt with no rights vested in the inventor or creator. So if my boss, I work in the Center for Technology Transfer and Commercialization. My boss tells me to develop a software application to manage what goes on in that office. That's a work for hire because I was specifically directed to do something. And I'm not a faculty member, and that makes a difference too, because there is a specific exception for discoveries or inventions made in the course of research where the results, although perhaps anticipated, are not directly or indirectly assigned. So it talks about the discovery and invention process. If you look at the history of the policy, it's pretty clear that it was meant to apply to faculty members to encourage the inventive and creative process. So it's an issue. If somebody has told you to do something, you ought to take a look at the policy or give one of us a call. This is the allocation of income. The policy was just recently amended about 12 or 18 months ago. It did not change the amount that inventors and authors receive. So for the first $100,000 each year, 50% is paid to inventors and authors, 20% to the department, 20% to the school, and 10% to the university. Once the revenue exceeds $100,000, then the inventor-author share drops to 40%, and the other shares are adjusted upwards by a total of 10%. And then each year that number, this gets reset. So you start with a brand new year, and the first $100,000 is once again subject to the 50% payable to inventors and authors. A couple things to keep in mind when about the policy and about startups in particular, which we're talking about today. If we license technology, whether it's to a startup or to an existing company, a big company, then royalties paid back to Vanderbilt. The royalties, remember, we'll talk a little bit about this today, the royalties could be in the form of cash or in the case of stock. Sometimes with startup companies, because startup companies like to preserve cash up front, it's difficult for them to pay cash royalties as a larger company would. We take stock in lieu of cash, or at least take some stock in lieu of some of the cash royalty. So all of that is subject to the technology policy if it's attributable to the license. Licensed technology to a startup or to a large company, the royalty paid back to Vanderbilt is distributed under this formula in the technology policy. However, if you have a role in the startup, let's say you're the chief science officer, chief technology officer in the startup, you're one of the founders of the startup, as Jim was, then that is a separate role, and that doesn't count into any of this. So what happens is authors, inventors, creators receive this share under the license, and then they would receive whatever they would receive as a founder or employee of the new startup company. So it's a pretty good deal for startup faculty members. Now we're going to talk a little bit more. Hassan is going to talk about conflict of interest and some of the things you need to think about, because there are a number of steps you have to consider before you can join a startup. And with that, I'll turn it over to Hassan.
The process begins for us with the disclosure. This is a formal process. There is an invention disclosure form that the inventor will fill out. It will note all the inventors that are there, their particulars, if there was any federal funding that helped or went into the research that resulted in the invention. That's important for us because we report that to the federal funding agency. So if you're a faculty member and you have an NIH grant that's up for renewal and you report, oh, by the way, I disclosed XYZ inventions, the NIH will come and ask us. And it doesn't count until we in our office reports it to the NIH that there was in fact an invention that came out of this particular grant. And the next step after that is evaluation. What you'll note about evaluation is that this is a major decision point. So there are several different directions that a technology can take. The story could end, and it could be closed, or we could, in concert with the inventor, say, well, you know what, this probably needs a little bit more. This is very early stage, and I'll talk about the early stages in a minute. So it's going to go back into the lab or back into your office and incubate there for a little bit, or it's going to go down this pathway to commercialization. And on the pathway to commercialization, this is the typical licensing to a third party to an established company. But then there's also this little box on the side, the new ventures and the spin-off thing, which Greg will expand upon. But notice that it comes back through marketing and through protection back towards licensing. So whatever happens to a particular technology, whether it's going to be licensed out to an established company or whether we spin it off, the way that asset is transferred to that entity is through a license. And that's where we come in and work in concert with the new ventures folks. So evaluation being such an important decision point, I just thought it would be good to spend a little bit of time talking about what it is. So the first thing to look at is what stage is it at? Are there any surgeons or physicians in the room? Okay, no. All right, I guess it's, oh, well, there's one. So, you know, before I came to Vanderbilt, the institution that I used to work with did a lot of medical devices. And a lot of times surgeons will come in and say, well, you know, this particular instrument that I hold in my hand is good, but it could be better if. And after that, there's a bunch of things that happen. If the grip could be different. If the cutting edge was at a different angle. If it could have 3 or more functionalities added onto it. In the same way, I see there's a bunch of postdoctoral researchers that I've had the pleasure of meeting and working with. And you know, you guys are doing a DNA prep or something like that. I personally would really like it if there was a machine where you could pour the bacteria off the top and the DNA comes out the bottom, and I don't have to do anything else, right? Now that's not an invention. That is an invitation to invent, and it's kind of a concept. It's kind of like the flying car, right? Like I really wish there was a flying car, but I don't know how to get to a flying car. I don't know what goes into making it. So that's more at the conceptual stage, and that is something which is a little bit too early. If someone comes to us, we'll probably advise them to go back, work on it a little bit more, come up with the who's, with the hows, and how to do it, and take it to the next stage, which would be the proof of concept. Translate your concept or your idea into reality, into something tangible. So if it's a medical device or if it's device-like, is there a prototype? And if there is a prototype, has there been some sort of validation that's been done, whether it's desktop validation, again, borrowing from the life sciences, if there is a surgical device of some sort, has it been tried on tissue or on organs? And better yet, has it been tried on animals in the whole organism kind of perspective? So the more sophisticated the proof of concept, the higher the value of the technology because it's been proven down the line. And validation, of course, goes into that. So once we've talked about the product itself, the next stage is the market. How big is the market? What opportunity does the invention present to us and to the patients and to the market itself? And how widely will it be accepted? So if there is a medication, let's say, that is an anti-cancer therapy, and it's effective 20% of the time, and it has terrible side effects. You lose all your hair, and you're vomiting all the time, all that stuff. And here's a researcher who comes up with a therapeutic that is effective 52% of the time, and has the same or worse side effects. Well, that's really not, is it going to penetrate the market all that much or not? We'll have to go into it, but it sounds like it won't. So, but if there is something, there's 20% efficacious, one medication, and a new thing comes along that's 50 to 60% efficacious. It's going to prolong the lifespan of the patient. It's going to improve their quality of life. All these things. Obviously, there's a need, and there is a higher probability of market penetration. That's something that would go into the evaluation. And hand in hand with penetration, of course, is the competitive environment. How many products are out there in the market? How many companies are there? Is there one big player and that's the only thing patients have or consumers have to work with and they're looking for alternatives? Or is it a buyer's market where there is a bunch of different options for a particular need? and just plugging in one new improvement into it will not address or will not solve the problem all that much. People will still keep on using many different things. For life science related inventions, for clinical inventions, of course, there is the regulatory piece. What is this going to look like? Is this going to be over the counter? Is this going to be direct to consumer? If it's a device, is it going through the 510K route? So the 510K route is a favorite amongst business development people because you could point to a predicate device, an existing device, and say, well, mine's an improvement, it does XYZ better in such and such a way, and it's relatively a simple pathway through the FDA. PMA is another pathway through the FDA, which is more complicated, and it's for drugs. And then outside of drugs, if for example, somebody's come up with a bug repellent as we've dealt with, and it's going to be sprayed on crops, is the EPA going to be used? Will the Environmental Protection Agency say, well, you can use it, or you can't use it, or you have to post-process the chemicals in a certain way before it can turn loose out there on the crops? And then pricing. Will this invention make money? So for those of you, if there's anybody who works in the diagnostic space in the room, you probably know, especially in molecular diagnostics, that the reimbursement as it stands right now, there are things that might have CPT codes. These are billing codes for insurance. For a lot of molecular tests, especially next generation sequencing tests, they will cost in excess of $1,000, $1,200, sometimes $2,000, $3,000. And the CPT reimbursement that exists for them right now, even with stacked codes, so if you take multiple codes saying that I'm doing this really complex DNA-based test, maxes out at under $500, $300, something like that. It's $26, I think, for each individual molecular step, and $30 for a physician to look at the results and provide an interpretation. So there is a clear gap over there between what the reimbursement is, what the money you get back from Medicare and Medicaid versus what you spend, and that is not a very attractive proposition for companies, and it's not a very good case for making a company. However, if there's money to be made, if there's going to be profit, clearly it's an enterprise that's sustainable, and we can go from there. So, coming into the other part of the evaluation, which is this little sidebar on new ventures, what are the considerations from the institution's point of view? So, what's important to understand over here is that the academic mindset, or what academia is focusing on, is going to be different from what the investors or the venture side of things is going to be thinking. The venture side of things is thinking about, here's a company, here's an asset, we're going to invest in it. We're going to take it to the market by the shortest, best suited route possible, get the money out, get an exit, and off we go. Hopefully, if everything works out fine, we're going to make money, and that's what we're in the business of. Academic institutions, of course, have other considerations because they have an academic mission, they have a mission of training, they have a mission to do research, so on and so forth. And all of that, the way that gets set up feeds into the academic mindset. So if we're going to go the company route, the first question is, does a university want a controlling share? Well, usually not. A lot of universities don't really want controlling share. What they want is for an investor to come in, put money into the company, and then take it somewhere. Take it because they're in the business of doing successful companies and exits. From an inventor's point of view, and certainly for the academic institution, conflict of interest is a big one because in the past 3 or 4 years, there are certain academic institutions that did end up on the front page of the Wall Street Journal for all the wrong reasons. That's not what you want because it affects donations, it affects fundraising, it affects grants in certain cases. And I'm going to talk about conflict of interest as it relates to the inventors themselves in just a little bit. Is there going to be direct versus indirect investment? So a lot of universities, the far majority of institutions, will do indirect investment. Those are things like Vanderbilt, university resources that go into the invention and the development of the product. So it's the lab space, the lights, the computing power, the cores, all that stuff that goes and helps in that product coming to fruition. it is also the investment that's made into the patent application, into the IP real estate that the university does. So for every disclosure that comes into our office, we, as the institution, are responsible. We incur the costs for patenting that, protecting that, and of course marketing that, taking that forward. There are a couple of institutions that do direct investment, and direct investment is seeding their own companies, but that has shown to be a rather unsustainable model because it's very high risk and who knows what the rewards are going to be like. So some universities have tried it in the past. I think Vanderbilt has tried it in the past. It didn't work out very well. So a lot of universities are going away from that. And hand in hand with that, with our investment and the asset that we're transferring over to the company, what kind of rights are we going to have on the board? So you would think that if I have an asset, and that asset is the reason for a company forming, and I'm putting that into a company, that I should have a say in the company. Well, that's a good idea if I'm an individual, because I can speak for myself, I can think for myself, and it all works great. But if I'm an academic institution, the next question comes up, which is, who's going to be the decision maker? Is it going to be the chancellor? Is it going to be a dean? Is it going to be the provost? Who is it going to be? And obviously, their primary job function at the institution is something else besides serving on a board. So taking that decision up to them and getting some guidance from them, it's going to take up a lot of time, and that's really not in our interest. That's not why we're in this business. What we want to know by participating in the board is to make sure that the product is developing as it should, that it is making progress towards the market as it should, and just keep up to date with what's going on. So in a lot of cases, observer rights are what are best suited for institutions, though some institutions, especially if they are in the business of direct investment in their own companies, want to have voting rights as well. All right, so here is the COI slide for the inventors. For you guys who have invented a technology, and now it's going to flow into a company. So the first thing is, of course, a quote-unquote conflict of interest. So if it's your baby, if it's your technology and it's going into a company, you're probably going to be on the scientific advisory, at the very least, if not being the chief technology officer or something like that. And if that is the case, there is a conflict of interest, and that has to be declared. And for Vanderbilt University, it's Dave Rayford in his office who deal with COI issues. So if you think that you have a conflict, and it's something, so the process is very simple. You declare a conflict of interest, and then with Dave Rayford's office, with the COI office, they come up with a plan to manage that conflict. And you stick to that plan, and it's all good. There is also a conflict of commitment, and for Vanderbilt, if memory serves me correctly, the policy is that a full-time Vanderbilt employee, staff or faculty, cannot spend a significant amount of time at an entity outside of Vanderbilt. And a significant amount of time is defined as 50 days a year. So if you're under 50 days a year working for your own little baby, for your company, or outside of Vanderbilt, you're good. If it's more than 50 days, then there is a conflict of commitment, and just like COI, it has to be declared, and you have to come up with a management plan. The management plan could be part-time, 1 minute at Vanderbilt, or something else. There are also NIH requirements that are coming into the whole COI equation, and I believe the NIH number is $5,000. So if you stand to make more than $5,000 from the company or the entity, that is considered a conflict, and it has to be declared and managed through the institution. So because of that $5,000 floor, I believe Vanderbilt had a higher number, but if you have federally funded research, because what's true for the NIH will soon become true for other federal granting agencies as well. So that undercuts everybody else's floor. And if that is an issue, and if the technology is something that's federally funded, you have to declare that as a conflict. And finally, the use of students in the research and development. So can PIs, can labs, can professors use their students in research and development? Well, they can use students, so certainly graduate students are part and parcel of the research enterprise, as are undergraduate students, and they can come up with an invention They can research the technology. There's this new thing that's going on. Do you believe it's true or not? Hand it off to an undergrad student. Do some controlled experiments over there. Tell me if it's real or not. That's all good, because that's all federally funded. Now that you have a thing, you have an invention, you cannot use students to develop that with an eye towards commercialization or utilizing commercial funds. So undergrad students especially, graduate students certainly as well, because for both of them there's a training and educational component that's built in, and I'm suspecting that for a lot of the graduate students here, and in your labs, they are federally funded, so there are federal guidelines that go against them being employed for the benefit of any commercial entity, and certainly can be taken. Postdocs and researchers or research associates, if they can be paid for their time from an appropriate grant, and you have to go and look at what kind of grant rules. If it's a postdoctoral grant, obviously it's not for research and development and training, basic research. But if their grant allows for it, and usually some grants allow for a postdoc and research associate a little bit of time to work on those technologies, or if there is sponsored research money that's coming in, and this is usually, sponsored research money is usually the norm more in relationships with quote-unquote established companies, the GSKs, the Bristol-Myers Squibbs, the Siemens of these big name companies rather than spin-off, because investors, certainly venture capitalists, would like for their money to go towards company development rather than conservation research. So if there is research money that's coming in, which is non-federal, non-university, that can go towards, that can enable you to hire a postdoc for the project for the research and development, or a research associate for the purpose. That's it. Any questions so far? Okay, so as I mentioned initially, whatever happens with the technology moving forward, if it's going to be commercialized, it's going to be through a license, because that is the vehicle for transferring the asset, whether it is to a startup company or to an established third-party company. And listed over here are a couple of the standard terms for any licensing agreement. So there's an upfront fee in the case of a newco, in the case of a spin-off company, it's usually in terms of equity rather than cash, because spin-off doesn't have that much cash. And for established companies, there is a cash payment that comes in. There is an understanding that patent expenses that are being incurred by Vanderbilt University to protect the asset, they will be reimbursed once a commercialization event happens. So NewCo gets on a payment plan of some sort to reimburse us for those patent costs. If this is with a company, with an established company that has an income stream, they would pay this lump usually. Diligence events, this is a function of the Bayh-Dole Act. So under the Bayh-Dole Act, federally funded inventions, there is a requirement to have them commercialized and bring them out to the benefit of the public if they are commercialized and licensed. So we just have to make sure that the technology, what diligence means is that the technology is moving forward. The company or the licensee is moving the technology forward. It's not sitting on a shelf somewhere. It is being developed in some way, shape, or form to be brought out into the market. And once it is brought out in the market, there will be sales, and Vanderbilt will get a piece, and through Vanderbilt, the inventors will get a piece of the income that is generated through royalty on sales. Hand in hand with licensed agreements, there is sponsored research that I alluded to earlier. This is usually the more established companies. Certainly there are certain venture capitalists in certain conditions who might come in and say, you know what, maybe we need to do another validation experiment. So here's a little bit of money to do that. That is certainly more the norm with established companies rather than with investors in newcos. And sponsored research usually goes hand in hand, sometimes with a license, but more often with an option agreement, and I'll tell you what an option agreement is in a little bit. One of the things that we all get hung up on, and we're going to have a more extensive conversation on, is future inventions. So how much of the future inventions do we give or promise to another company? Certainly if a newco is coming in, they will say, well, if I'm going to look attractive to investors, I need to lock all this space up. So I need to get the rights to the existing technology, whatever it is, and anything that comes out in the future, because whatever comes out in the future is going to be good for me if I license it, but if you license it to somebody else, they're going to be my competitor. And we again come back to diligence. What is the ability of the company to take all that to the market and to hedge our bets? And so one of the things that we'll say is, okay, fine, you can take the improvements, but you can take them in a certain fee. So license agreements are akin to marriages. I mean, it's where we and another company do get married of sorts. It's a long-term relationship. Patents usually last for about 20 years from the date of first application. So a license agreement, if everything goes well, if there's no divorce or termination, they will last for 20 years. These are shorter-term agreements, so there is something called a standstill agreement, which is about 1 to 3 months in length. It is free to the company, and the understanding over here is that we will continue marketing the technology, but we won't enter into a transaction with a third party. So in the 1 to 3 months that you have under the standstill, you can go ahead and vet the business opportunity, do your own diligence, Mr. Investor or company, whoever you are, and then come back to me and tell me what you want. And if you want to take us on, we'll talk about getting married. If you don't want it, we'll go away. So there's no issues over there. Something along those lines, but a little bit more solid and more akin to an engagement is what's called an option agreement. And this is up to a year. There is a fee, and what an option agreement entails is in return for the payment of the fee, the technology goes off the market. So because we have monetary consideration from the company, we will not market this to any third parties, and of course we won't enter into any transactions. And this will allow, and if there is any patent expenses that are undertaken during the option period, the optionee would have to pay us for that, just like they would under a license agreement. But it's term limited, it's up to a year. And this is where, for early stage technologies, where there's more investment that needs to come in into the development of the technology. So, I need to do a proof of concept to see if this is going to go anywhere. I have money in my budget to do that, so I'm going to go ahead and do that before I take a license from the university. So something like that. So if options work out, and options go hand in hand with a sponsored research agreement usually, that we talked about earlier, and if this works out, then the option can be exercised and you can start licensing.
My name is Rupert Joshi. I am a manager with the New Ventures Group. I work with Peter, and we're really an extension of CTCC. Our objective is pretty simple, really to facilitate and foster and accelerate new venture creation at Vanderbilt. And really to be a go-to support for our faculty, for our inventors, for entrepreneurs who are looking to spin off ventures out of Vanderbilt University. So we'll talk a little bit about the process, the new ventures support process. Really, it's an extension of the licensing process. And it's to really allow us to vet technologies and allow us to explore new venture creation at Vanderbilt. The first part of this process is really business disclosure. This is essentially a fact-finding phase where we get together with the faculty member, with the inventor or the entrepreneur, and really establish a working relationship in order to explore the technology and explore the idea from a new venture creation standpoint. We want it to be a creative dialogue. We want it to be an iterative process whereby we give enough chance to understand and assess and evaluate whether we really want to go forward in terms of the idea from a new venture creation standpoint. So what are we trying to do in the business disclosure phase? We sit down with the inventor, we go through a question-answer session. We are able to understand where he or she is coming from, what is his logic or her logic in terms of starting a new venture, and his level of understanding in terms of what it takes to actually create a new business, actually spin off a company. It also allows us to gauge the level of commitment that the inventor or the faculty member is willing to put in as a part of this exercise. And again, it's a collaborative process. It's a partnership that we want to create with our faculty, with our inventors. It's a service that we provide in order to really assess, really be able to understand whether the technology makes sense in terms of spinning it out. So what are we trying to do in terms of fact finding? Really, we're trying to understand at this very early stage, is there sufficient is it an attractive market opportunity? Is the technology good? Is the offered solution feasible? Is the technology defensible? Is there really a good market in terms of whether this technology can be taken forward? Can this technology or can this idea or service, can it be packaged in the right way? Is it investable? Is what we are trying to do in this first business disclosure, fact finding. So, what are the few things that we do? We conduct entrepreneur faculty interview, and this is again, as I mentioned earlier, it's an initial concept review, is to understand, get into the mind of the inventor, and really to just do a preliminary due diligence and evaluation in terms of the idea, the technology from a new venture creation standpoint. And again, it ties in very closely in terms of the due diligence that we do on the licensing side, but here the specific focus is the idea scalable? Is the technology scalable? Is it investable? Can it be patented? And will somebody be willing to look at it? When I say somebody, it's really the investor community in terms of putting in money to take this forward into a true commercialization route. The second process, post business disclosure, post this initial meeting, is really an internal due diligence process. Very similar to what I have experienced in my venture capital and private equity days, is to really assess, understand, and go deeper, dig deeper into the technology, into the invention, and really see if we want to take this forward, if we want to spend more time on this from a new venture creation perspective. So really a 360-degree review, studying the technology, really defining the value proposition, understanding the proposition, what is disruptive as a result of this offering. Can this really make it to market? What is the competitive landscape? What is the cost structure? How much is it going to cost us to actually build this? So really get into the nitty-gritties of understanding and get into the nitty-gritties of really evaluating the technology and the business from an investability standpoint. So we are looking at the revenue model. We are trying to formulate a business structure, a business model, and come up with a strategy by which we can actually spin this off into a new venture. This is an important process because it really ties into, it's the beginning of the business plan creation process. It allows us to understand whether this will definitely, whether this is something that definitely we want to put our time into. A lot of times we get deal flow where, it may seem like an excellent idea to an inventor or a faculty member, but when we go through the process of an internal due diligence and we really evaluate the technology, the idea from different perspectives, from a technology perspective, from a team dynamic perspective, from a market perspective, it just may not make sense to go through the startup route. So again, the idea here is to dig deeper, go 5 or 10 levels deeper, as opposed to from the first process, and really be able to say, yes, we want to go ahead with this, or no, we don't want to go ahead with this because of so and so, whatever the reason is. We also have a process of vetting this, the ideas, vetting the technologies through an external route. Again, the logic is very simple. We want to get an early assessment from our ecosystem, whereby we get positive indication that yes, this is something that is investable. This is something that will fly. This is something that VCs will consider, and this is something that can actually exit out of Vanderbilt in the form of a new venture. Once we're able to get that that validation, at least an initial assessment from our ecosystem, from our advisors, mentors, whoever we talk to, we have a good comfort level to say yes. At this point, we want to go ahead and dig deeper, get to the business framework so that we can package this technology, this idea into an invention. Again, throughout this entire process, we want to make sure that we have the buy-in, we have the right kind of attention from the inventor and from the faculty member. We cannot do this by ourselves. We're not here to spoon feed our expertise or our services to the inventor. We want to be there and work with the inventor, work with the faculty in a collaborative process. We want to be able to give him or her the right kind of guidance to be able to get through this process of internal due diligence, get through this process of business plan creation and whatever that is required in order to package it for the ultimate audience, which may be the investment community, the VC community again. So if you're able to determine whether it's a go, it's pretty obvious. The real question we're trying to answer here is this something that somebody would invest in? Would one really put money into a venture like this? It's the go aspect of it is again monetization. The key word here is scalability, an attractive value proposition, and of course an addressable market. So if we're able to establish through the due diligence process that the venture does merit a spin-off, then we will go ahead and give it a go. We will give it a go ahead in order to explore the venture further. That means going through the strategic planning process, going through the process of actually creating a business plan and so on and so forth. A lot of times, a majority of the times, we would come to the conclusion that this would actually be a no-go. So what does no-go really mean? I've sort of mentioned it over here. Recommend a go, no-go. We talked about go. A no-go is basically could mean two things. One is it may require further development of the business model. It may mean that we need to go back to the drawing board. The idea has some merit, or the invention has some merit, but it may not be right in terms of actually spinning off into a new venture at this moment of time. So we go back to the drawing board, we reassess, regroup, and reevaluate this technology maybe at a later stage, come up with a plan in order to re-engage with the inventor over a course of time. The other path that may result from no-go is an alternate monetization strategy. There's just certain technologies that we feel, that we come across that just may not merit the time, the effort, and the idea of spinning off into a new venture. This could be lack of market potential, very high R&D costs, and regulatory constraints. They're typically technologies that fall into life science and the biotech, as in terms of our experience, would typically fall into these categories where you would want to explore alternate monetization strategies. What would they be? Intellectual property licensing. I think Hassan touched upon that. Collaborative research and development. I think this is a way to monetize, an alternate way to monetize, and then actually the outright sale of technology to a strategic market. And typically, we've been fortunate enough that we are getting enough deal flow where anywhere between 2 to 3% of the technologies or the ideas, the inventions that come through the door actually merit us looking at them and spending the time and effort to go through this entire process of investigation. Most of them would either be a straight no-go, you're going to go back to the drawing board, or they basically come, the evaluation really clearly tells us that this is something that we would rather monetize through an alternate product. So once it goes through the go process, we get a good feedback from our external partners, mentors. We'll say, okay, let's go forward. Let's look at this further. Let's start building the business plan. We've gone through the due diligence process. We've gathered a significant amount of data, competitive information about the competitive landscape, and now we want to put everything together and package this so that we can get this out to the right people. So strategic planning really is, again, a process that is a part of the business planning process. We want to define the business mission, we want to set corporate objectives, really what is it that we want to do, and how are we going to package, how are we going to really create a sustainable proposition for a potential investor. Of course, analyze the internal external environment. This is from a company perspective. What does the business look like? What are the strengths? What are the weaknesses? What are the opportunities? And what are the threats? And then, of course, evaluating the competitive strategies. How are you going to create a value proposition, and how are you going to stand out vis-a-vis your competition? The following, and this sort of translates into the actual development of the business plan. Again, I would like to reiterate, this is a collaborative process. One cannot expect us to write business plans wholeheartedly for our inventors and for our faculty. We want to be there. We want to provide input. We've had several cases where we actually get our faculty, our inventors who come with business plans, and this is a great way for us to provide our feedback and provide our expertise in terms of fine-tuning the document or whatever. In certain cases, we actually help the faculty or the inventor actually craft the business plan as well. Typically, what is a business plan? I think Peter wanted me to talk a little bit about the actual document as such. It's really a framework that you want to convey. It's really a framework for your startup. It basically conveys what you are trying to do. It basically conveys your revenue model. That's how are you going to make money. It basically conveys what is your technology, your service all about, and ultimately it talks about how are you going to make money. What are your projections look like? What is your revenue model? What is your cost structure from a financial perspective? So we will help develop the business plan. We will help in certain cases participate in the actual writing of the business plan. Again, similarly, we'll help develop the financial and valuation model. A lot of times, our faculty and inventors are raw in this particular area, and it may require that we have to give more time to our inventors, to our faculty members as a part of this venture creation process, which is absolutely fine. But we want to see effort coming from the other side as well. So it's a collaborative process again. We also want to analyze funding needs and how those funding needs are going to translate into creating, taking the business from the university level to commercialization. So what are the use of funds? What is the VC money, or what is? Sorry, go ahead.
Just wanted to ask if you could use the mic, perhaps. It's a little hard to hear in the back.
Is it better?
Much better. Thank you.
Yeah, so again, we want to analyze the funding needs and use of funds. This is the area where we really want to determine how much is needed. We want to make sure that we don't ask for too much. We want to make sure that we don't ask for too little. At the end of the day, this is a critical component, because if you ask for too much, you're going to end up giving a lot of equity at this stage in the evolution of the new venture, at this stage of evolution for the startup. Typically, in the venture capital world, the riskier the proposition, the more equity you have to give up. So we want to make sure that we assess these funding needs in a manner where we ask what is needed to the minimum and make sure that it becomes a win-win for both. And then we evaluate the investment options. So what are the various sources of investment pools that we can tap into? Direct investment, of course, pre-seed funding, that's typically less than $500,000, maybe even less. So you have your angel networks, of course you have grants, you have the 3 Fs, which are family, friends, and fools, and you have the strategic partners. On the grants front, I think is an important aspect at this stage, because a lot of times it becomes hard for us to seek that initial pre-seed funding. It's a tough process, and especially given the ecosystem here, it's definitely a challenge in terms of getting that initial 200, 300K that may be required to just get the company ripe or ready for the actual Series era. There may be technology, there may be situations where you would not need pre-seed funding. We've got companies where they've survived with bootstrap, and they've got it to a point where they're actually ready for the Series A. So in that case, that form of direct funding would come from traditional venture capital sources, could come from high net worth individuals, follow-on grants, SBR, CTR grants, especially phase 2s, they go into larger amounts, and then of course strategic partners who may want to invest into this sort of venture. Indirect, of course, proof of concept funding. We have a small fund in-house. It's not a large sum of money, but it's called the Technology Maturation Fund. And the idea is to just provide enough capital to get proof of concept for the company, for the venture, and get it to a point where we can package it and then market it to the investment community. Again, it's not a Series A fund. It's not a university fund. It's a CTTC fund. Sorry, specifically about 300 to 400K that we have in a pool that we allocate to inventors, to technologies that we feel are pretty promising, and that we can eventually license or spin off into a venture. Patent expense deferment. Again, this is